Something unusual happened in Yellowstone's Biscuit Basin at 5:09 in the morning on June 13th, 2026. The ground did not shake in the way most people imagine when they think about this place. There was no dramatic warning, no escalating tremor that sent birds into the air. Instead, the newest monitoring equipment installed by the Yellowstone Volcano Observatory, sensors placed precisely because this exact location had already proven unpredictable, registered a burst of seismic energy and a low-frequency acoustic pulse that scientists call infrasound. Then a camera mounted near Black Diamond Pool captured something that park staff would not see until sunrise, a dark column of steam and debris jetting violently out of the earth from a patch of ground that had not previously been a vent at all. By the time the sun was fully up, park rangers noticed the Firehole River had turned a pale milky gray. That discoloration stretched 6 kilometers downstream all the way to Midway Geyser Basin. 2 new runoff channels had opened overnight, pouring sediment-rich, near-boiling water directly into the river. When geologists arrived to assess the site, they found something that did not exist the day before, a fissure in the ground measuring approximately 18.5 meters long and up to 1.5 meters wide in places, filled with water sitting at 90 degrees Celsius, nearly at boiling point for that elevation. Rocks had been thrown across the surrounding ground, and in the days that followed, a new pool of boiling water formed in the disturbed earth, appearing sometime between June 14th and 16th, as if the land had simply decided to create it. This was not the first time Biscuit Basin had done something like this. On July 23rd, 2024, the same area, specifically centered on Black Diamond Pool, experienced a significantly larger hydrothermal explosion that sent rocks flying, destroyed a visitor boardwalk, and discharged a visible plume of steam, mud, and debris into the sky. That event rattled scientists, not because of its immediate scale, but because of what it revealed. Hydrothermal explosions at Yellowstone are far more frequent and far less predictable than most people understood. They do not require a volcanic eruption. They do not require the magma reservoir to move. All they require is a moment when the pressure inside the shallow hot water plumbing system builds faster than the ground above it can contain. That process begins with silica, the same mineral that makes Yellowstone's thermal pools glow with such impossible color. As silica dissolved in superheated water gradually clogs underground conduits, pressure differences build. When the balance finally breaks, water that is already at or near boiling temperature flashes almost instantly into steam. The expansion is violent. The ground has no choice. And the June 13th event is now the 6th confirmed hydrothermal explosion at the Black Diamond Pool area since monitoring instruments were placed there in summer 2025. In total, across 2026 alone, scientists have recorded 5 small hydrothermal explosions in the Biscuit Basin thermal area. That is not one anomaly. That is a pattern. The June explosion took place 30 to 60 meters north of Black Diamond Pool and was well recorded by the seismic and acoustic monitoring equipment installed after the 2024 event. The system that detected it is exactly the kind of close-range, basin-specific instrumentation that Yellowstone's monitoring plan identified as a critical gap only a few years ago. The regional seismic network, the one most people think of when they imagine Yellowstone being watched, is designed to catch earthquakes and broad deformation trends. It was never built to catch the small, sharp, shallow signals that precede a hydrothermal event. The newer sensors can. And what they caught on the morning of June 13th was Biscuit Basin doing something it has now done repeatedly at the same location in a sequence that scientists are actively studying. In July 2026, the Yellowstone Volcano Observatory announced plans to begin installation of a new monitoring station in Upper Geyser Basin, the area surrounding Old Faithful, less than 2 miles from Biscuit Basin itself. That decision did not come from nowhere. It reflects a deliberate expansion of close-range monitoring into the very thermal zones where the June explosion occurred. Scientists are not reacting to a crisis. They're responding to a demonstrated need. The ground in this part of Yellowstone has shown repeatedly and recently that shallow hydrothermal events happen in places and at times that older, wider net monitoring was not capturing. The new station will add seismic and infrasound sensors to a basin that sits at the heart of Yellowstone's most visited terrain. What makes the current situation genuinely worth watching is not any single explosion in isolation. It is the accumulation of signals that have been building across this system over the past 12 months. Signals that, taken individually, fall well within the range of what Yellowstone does. Taken together, they form a picture that scientists are paying close attention to, and that picture is more layered than most coverage has managed to explain. To understand why the pattern matters, you need to go back to July 2025, not to Biscuit Basin, but to a strip of ground on the north rim of Yellowstone's caldera, just south of Norris Geyser Basin. That is where something began moving. In July 2025, continuous GPS stations on the northwest side of Yellowstone caldera began shifting outward, away from a central point on the North Caldera rim. One station near Madison Junction moved steadily to the southwest. A station near Norris Junction moved in the opposite direction to the northeast. Both were moving away from the same center, the way two sides of an inflating balloon move apart from the Norris Uplift anomaly, or NUA, because of a previous episode of deformation that occurred in the same location between 1996 and 2004. That earlier episode lasted nearly a decade, produced measurable ground rise, and then quietly ended. After that, the area was mostly still for over 20 years. No significant changes occurred after 2020, with the possible exception of about 1 centimeter of movement during 2020 to 2022. Until July 2025, that was where things stood. Between July and September 2025, the ground in the core of the Norris Uplift anomaly rose by almost 2 centimeters. That number sounds small. In the context of a supervolcanic system being measured in fractions of an inch, 2 centimeters of surface rise over a few months is a signal worth noting. INSAR data, radar imagery collected by satellite, confirmed what the GPS stations were recording on the ground. The uplift was real, localized, and centered on a specific area that had behaved this way once before in a period that scientists already understood to reflect something happening deep beneath the surface. The deformation at the Norris Uplift anomaly probably reflects magmatic activity at approximately 14 kilometers beneath the surface, roughly 9 miles down. That depth is important. At 14 kilometers, you're not talking about shallow hydrothermal plumbing. You're not talking about the upper crust rearranging itself due to water movement or seasonal frost. You are talking about a zone close to, or within, the deeper crustal reservoir system that sits above Yellowstone's partially molten magma body. The USGS is careful to say this clearly. The uplift does not indicate an increased chance of eruption. It reflects the dynamic behavior that is normal for a system of this scale, but that only modern monitoring technology is capable of detecting with this level of precision. The uplift that started in July 2025 on the North Caldera rim ceased by mid-January 2026. GPS data flattened. The ground stopped rising. But what followed in the weeks and months after that pause is where the story gets more complicated, because even as the ground deformation quieted at the Norris Uplift anomaly, 2 other systems within Yellowstone began doing things they had not done in years. A Echinus geyser in Norris Geyser Basin erupted approximately 40 times between February 7th and February 24th, 2026. Its first eruption since December 2020. Echinus is not a geyser that most visitors know. It does not have the celebrity of Old Faithful or the raw scale of Steamboat. But among scientists who study Yellowstone's hydrothermal system, Echinus holds a specific significance. Norris Geyser Basin is the hottest and most geologically dynamic basin in the entire park. It sits directly adjacent to the area where the 2025 ground uplift occurred. And a geyser in that basin that had been silent for more than 5 years, abruptly reactivating across dozens of eruptions in a single month, is exactly the kind of shift that prompts closer attention. Not alarm, but attention. This is also the first winter since 2015 to 2016 during which Yellowstone caldera showed no subsidence at all. Every winter for nearly a decade, the caldera had sunk slightly as colder temperatures and reduced hydrothermal circulation caused the ground to contract. That pattern did not repeat this past winter. The caldera did not subside in the usual way. Scientists describe this as a subtle change in the style of caldera deformation, not a dramatic departure, but a measurable one. The ground is behaving differently than it has for the better part of 10 years. And that change, together with a reactivated geyser, the ground uplift that ran through the second half of 2025, and the repeated hydrothermal explosions at Biscuit Basin, form a sequence that the Yellowstone Volcano Observatory is now monitoring with a level of granularity that was not technically possible even 5 years ago. That last point is worth sitting with. The reason we know about these overlapping signals is not because Yellowstone has necessarily become more active. It may simply be that the monitoring network has become precise enough to catch things it was always missing. A study published in Science Advances used machine learning to re-examine historical earthquake data from the Yellowstone caldera over a 15-year period. The team was able to detect and assign magnitudes to approximately 10 times more seismic events than had previously been recorded. 10 times. The earthquakes were always happening. The instruments just could not hear them. Now they can. And what that means for interpreting the current signals is something scientists are actively working through. There is a version of this story that gets told badly. It goes like this. Yellowstone is stirring, the ground is moving, geysers are waking up, and explosions are happening near Old Faithful. That version is technically accurate in almost every individual detail. And it is deeply misleading in the conclusion it invites people to draw. The reality is more precise, more interesting, and ultimately more unsettling in a different way, not because an eruption is coming, but because the system operating beneath this landscape is far more complex and far more active than the simplified version of Yellowstone that most people carry in their heads. If Yellowstone were genuinely building toward a volcanic eruption, scientists would expect to see years of escalating signals, persistent earthquake swarms with magnitudes increasing over months, sustained ground uplift measured in meters rather than centimeters, dramatically increased gas emissions, and new thermal features appearing across wide areas of the park. None of that is happening. The current volcano alert level remains at normal. The aviation color code is green. The USGS has not issued any elevated advisory. These are not formalities. They are the output of a monitoring system that watches Yellowstone around the clock across dozens of sensor types, and they reflect the genuine scientific assessment of where the system stands right now. But here is what that same monitoring system is also showing, and what rarely gets explained clearly enough. Yellowstone's hydrothermal system, the network of superheated water, steam, dissolved minerals, and pressurized underground plumbing that powers every geyser, hot spring, and fumarole in the park, operates on a completely separate timeline from its volcanic system. A hydrothermal explosion does not require magma to move. It does not require the deep reservoir to change at all. It requires only a shift in the shallow underground pressure balance, a blocked conduit, a drop in the water table, a sudden release of confined steam. According to the Yellowstone Volcano Observatory, hydrothermal explosions are violent and dramatic events resulting in the rapid ejection of boiling water, steam, mud, and rock fragments driven by sudden pressure, changes from the rapid transition of liquid water to steam. That process can happen with no warning detectable at the surface, and at Biscuit Basin in 2026, it has happened 6 times in the span of a year. The question scientists are now focused on is whether the clustering of explosions at this specific location reflects something changing in the local hydrothermal plumbing or something shifting in the broader thermal system across this part of the park. Those are different problems, with different implications. If it is purely local, a single conduit system beneath Black Diamond Pool that has been repeatedly destabilized since the large 2024 explosion cracked the ground and reorganized the subsurface drainage, then the current activity, while hazardous for visitors in that area, tells us relatively little about conditions across the wider system. The June 13th explosion opened several vent groups across a fissure about 18.5 meters long, and geologists observed that the only vent still sending water to the river at the time of their visit was the northernmost one, farthest from Black Diamond Pool itself. That migration of activity, moving progressively further from the original 2024 explosion site, is something researchers are tracking carefully. If, on the other hand, the repeated explosions reflect a broader shift in hydrothermal pressure or temperature across this section of Yellowstone's upper thermal system, then they connect to the other signals in a way that becomes harder to dismiss as coincidence. The North Caldera Rim uplift that ran from July to January, the reactivation of a Kindness geyser after 5 years of silence, the unusual absence of winter, caldera subsidence. The largest recorded hydrothermal eruption at Black Diamond Pool since monitoring instruments were installed occurred in April 2026 on the 29th, ejecting muddy water and steam toward the monitoring camera. Each of these events individually has a plausible and contained explanation. Together, they describe a system that is not in crisis, but is also not in a quiet phase. Something is shifting in the thermal and mechanical balance of this part of Yellowstone. Scientists are not yet certain what is driving it or how far it extends. The machine learning study that uncovered approximately 86,000 previously undetected earthquakes beneath Yellowstone over 15 years found that many of these hidden events clustered into swarms that were never recognized at the time. That finding has a direct bearing on the current situation. If historical data, re-examined with modern tools, reveals swarm activity that was invisible to the original monitoring network, then the question of whether current activity is genuinely elevated, or simply better observed, becomes one of the central scientific puzzles in Yellowstone research right now. The answer is not yet clear. And the honest position, the one that serious researchers are maintaining, is that both things may be true simultaneously. Monitoring has improved, and the system may also be in a modestly more active phase than its long-term average. That honest uncertainty is not a weakness in the science. It is the science working correctly. Yellowstone is a system of extraordinary scale, operating across timescales that dwarf human observation. The monitoring network watching it today is the most capable in the history of this park. And what that network is returning right now in the summer of 2026 is a set of signals that are not alarming individually, but that, read together and in sequence, are telling scientists something worth listening to very closely.